Now then guys, I hope that you're keeping well. I've got a processing tutorial for you on M51, the Whirlpool Galaxy. If you want to work alongside me, just check the link in the description box down below this video and you'll find a link to my Google Drive which contains the data that I'm going to be working on today, available to you, of course, free of charge, so we can all learn together. Now I'm also going to tack onto this a processing challenge should you wish to take part. Once you've processed the data, you can post your result on Instagram and use the hashtag somewhere in your description of hashtag Whirlpool, where it's all one word, and I'll be able to find it then at a later date and make another video where we're going to take a look at everybody's submissions and rate them one after the other. I think it's a really useful way to learn. I've certainly found some use from it already. So we are, of course, going to be using PixInsight for this, along with the tools, the good tools, BlurXTerminator, NoiseXTerminator, StarXTerminator. You're free to use whatever you wish. Of course, it's useful if you do put any processing information into the submission as part of your Instagram post, though. If you do want to have your images rated, that does help us figure out what you were using. But for me, I own these tools. I think they're the best, so I'm going to use them. I do have affiliate links down below if you want to use those. I really appreciate the support that you guys give through those. There are trials available, and a massive thanks to everybody who's already used those as well. You guys are the best. I really do thank you for thinking of me and using those. So all that said, let's get started with this thing. First things first, I'm going to apply an STF. So we can take a look at what's exactly in this image. Now, as you can see, there's a lot of stacking artifacts. There's a large gradient currently going from right to left. That will flip because we are going to have to flip this data anyway, given that it was taken with a Hyperstar single mirror system. It's currently having that mirrored effect. But all that aside, let's deal with problems as we come across them. So first thing is going to be dealing with the crop right here. So let's just take care of that. Just going to pull in from the corners until I finish. Basically, I want to make sure I've got rid of everything right there. With the middle of the crop window just settled around about on the core of M51. I think that will frame things overall quite nicely for us. Let's go ahead and apply that. We can increase very slightly the size of the window just to take a good look at what we're dealing with. Now this gradient, of course, let's just flip this the right way around. So fast rotation is the tool I'm going to use, and apply a horizontal mirror for this. That looks correct. And next up, of course, we've got this large gradient now going from left, brighter, right, darker. And it's obviously really distracting, and we can't really continue processing without getting rid of that. So I'm going to try to get rid of it using Toolbox GradientXpert. This is a fantastic free tool. It really, generally speaking, does a great job. And now let's just see what we come up with right now. So overall, not bad. Although I am going to say, actually, I'm not completely satisfied with the GradientXpert's result there. It looks to, if I just zoom out a touch, maybe I've sunk M51 very slightly back, so it's recessed it, and there's also a line that's left through quite here. So I'm going to leave this in, of course. This is a perfect opportunity to try to go a different route and just hope that this way works. So this is how things go, of course. While processing, you find new challenges and new ways of dealing the challenges when your old ways don't really work. So let's have a go now. Bypass the gradient just for now. We're going to go ahead and solve the image and eventually work our way through to using multi-scale gradient correction. But to do that, first off, we need to plate solve this image. So I'm going to go to Scripts, Astrometry, and Image Solver. So I'm going to search for M51. All right there, Messier 51, the Whirlpool. Make sure that's selected. You want to follow along, of course, with this. You are going to need to use this input data. So 540 mils of focal length, 2.9 micron pixel size. Make sure you hit enter after that, just to make sure that your resolution has updated in this window. It should be reading 1.108 arc seconds per pixel. Go ahead and let it solve it at this. All right, seems to have actually worked just fine. Next up, we can go ahead to spectrophotometric color calibration. That's going to apply a color calibration to our image. Usually works wonderfully well. It's a really robust tool at this point. Now, oftentimes, if you've got one of these sensors right here, you should be using the drop-down curve to select the correct quantum efficiency curve for your camera. As the 585 that I used for this isn't included, we are just going to stick with the ideal curve and go ahead and let it do its best. And it looks to have followed the midpoint of the graph nicely. And that looks pretty good, aside from that really, at this point, very ugly gradient. So next up, as part of the processing beforehand, before using multiscale gradient correction, we need to pass it through spectrophotometric flux calibration. Try that after, I'm saying that after 3 pints. But anyway, again, we can't choose the quantum efficiency curve. We're going to have to just go with the ideal and go ahead and see if it can solve. All right, that appears to have worked. We've now got the flux calibration finished. Sounds very scientific indeed. Next up, we're going to finish off with multiscale gradient correction. This can be a pretty useful tool, although it isn't, I would say, the most user-friendly. I recently found some use from it on some challenging M63 data that I captured, and I'm hoping that it can pull the cat out of the bag for us on this one. But we'll give it a go, just at defaults, and see what we come up with. And have that done in just a moment. If we stretch the background gradient model, it doesn't look too bad. Although I would say there's still definitely fair to say some remnant gradient on the right and left, and even a little bit of evidence still of that that kind of channel down to the left-hand side of the image. So I'm going to undo on that, and now we're going to try dropping down the scale of the gradients that it's trying to analyze. I think we'll drop it right down. We'll give it a go at 384. This can be an iterative process. You may have to try a few different times in order to land on a good solution. You can see it's just got the faintest halo, perhaps, of some of M51's data there that might have been extracted, but overall, that looks pretty flat. I think, for the purposes of this, it's done a great job right there. Actually, I'm really quite happy with that overall. Yeah, we're going to move on out of that. So it seems that if you want to copy my settings, it seems that a gradient scale of 384 without any need for further model smoothness or structure separation actually worked in my case. So that's good to know. Just while editing together this video, I wanted to jump in and add a little bit extra for you right here, just to let you know that at this point in the tutorial, as in right now, it would probably be worth your time to at least experiment with running SPCC once again on your data. Now it's at this current phase, right before moving things along. I've played around a little bit more myself, and I found that it can, in some cases, be beneficial to do that. So, you know, make a clone perhaps, run SPCC again on one of them and leave the other one as is, but by all means, you know, experiment, have a go, that's what it's all about. Now, the next steps of processing are going to be to start working through the Exterminator tools. So in my case, first off, going to be BlurXTerminator, and I think this is another actual decent point where we can do a little bit of an experiment to hopefully learn from. So I'm just made a clone there just by dragging out from the this side identifier. As you can see, that little tab. Just going to select this, click window and tile, and now I've got two images side by side, both the exact same thing. I'm going to zoom into a view that I find usable for this, clone that view across. And now we've got two images prepared that we can test on right away. So the left-hand side, the clone that I made, I'm going to just go ahead and try to apply a defaults on this one. Now that's worked well, I have to say. There appears to be nothing really wrong with that overall. If I'm being honest, I could actually just settle at that and move on. But I will, for the sake of experimentation and demonstration, just give it another quick go with sharpen stars mode cranked right the way up to the top. Could end up needing to increase the adjust star halos value just a bit in order to stop pitting kind of appearing around these stars very slightly. So we'll give it a try at 0.25. If it needs more, it needs more. That's fine. But we're also going to fully crank sharpen non-stellar and really give this thing the beans and see what it comes up with. I have to say that looks phenomenal. Yeah, I really like that. I'm going to go ahead with that, actually. I think that's that's nicely settled for me. So I'll close down the clone. Again, like I said, that was just a bit of an experiment that it seemed appropriate to do at that time. Now, next, obviously there's still some noise in this image before we even start applying further processing tools, you know, stretching. So let's tackle it. NoiseXTerminator comes on with these as its defaults. I think that's probably going to be absolutely fine because it's not that noisy. Well, let's give it a go. Let's see what it comes up with. And once again, honestly, these tools make me happy to use every time I've tried them. I've never once regretted the money spent. It really is fantastic. Yeah, no need to actually go further than that. It appears to be noise free, looks absolutely wonderful, all details preserved. You know, you can see undo, redo. These things are like magic. Again, affiliate links if you want to try them out, but if you've already got them, you'll be in the know. You know what they're like. Absolutely wonderful. Next step, anyway, moving on, is going to be to take this image into the non-linear phase. So it's currently completely linear. You can see if we just undo the STF, it's back to a black screen, effectively. So to stretch this, I'm just going to re-STF a moment, get an idea of where we've got some background. There appears to still be some small gradient, but let's say up here, that's absolutely fine. That should be a decent reference for us. So I'll reset the STF, turn that off, open up generalized hyperbolic stretch. This is my preferred way of stretching. I'm going to apply from up here just by holding down the left mouse click on a sample area. Click send to SP, that's the symmetry point through which the data is going to be transformed. And with it on generalized hyperbolic mode, I'm going to then up the stretch factor. So first off, just create a preview, start to increase the stretch factor until the data is becoming stretched, of course, and visible for us to work with. Now, there are a few indicators in the generalized hyperbolic stretch window's histogram as to what's going on with your data, actually. So let's say if I stretch it too far, you can see things are starting to break down. Of course, we've lost the core and all that lot, but you can see the data really is beginning to break down and become kind of blocky in its appearance on that histogram. Now, that's certainly not what we're looking for, but we can take it further than it was. So I'd say if we leave things around about there, that looks good. The histogram isn't yet breaking down. If I just increase the size of that, I should make it a little bit more friendly for you to view. It's just very slightly getting shonky, but that looks fine to me. Now, next up, I'm just going to drag in the preview box so we can take a closer look at M51. You can see the cores totally burned out. Even the neighboring galaxy that's being consumed right there is also burned out. So next up, we're going to slide along the local intensity before we apply this stretch. Now you can see the effect that that's having. That is altering how it looks completely, and it's just like a magic transformation at that point, going from this, just a burned out mess, stars are massive and things like that, to just tearing it back really rather tastefully. And I think it looks good for me about there. I'm going to say I'm satisfied at that. Go ahead, apply, reset the tool, change from transformation type generalized hyperbolic to linear. And now we're going to take the left hand side of this histogram Windows tool, just drag it along until we've set our black point where we want it to be. So for me, I think around about there looks good. Now, some of these small remnant gradients, they're left behind. I think they should be easy for GradientXpert to tackle at this point. So I'm going to try once more with GradientXpert. This is just, you know, I think experience speaking at this point. When it's not too, you know, dastardly, the sort of gradients that you see in your image, it can usually take care of them completely competently. And as you can see right there, it did. We've now rebiased our image background to a wonderful flat grey. I think that looks absolutely spot on. We've not really taken anything out of anywhere else. So overall, I'm very, very happy with the processing at that point. Now I'm just going to apply a blanket curves of saturation to this image. A very small amount. Don't overdo it, of course, and start making your background look weird coloured, a little bit 60s psychedelic. Instead, just a touch is all that's needed to take it away from just being a totally flat, almost monochromatic grey, to having a little bit of life. But we are going to add some more to it just later on. So I've applied that. One step is all it needed. It's now been changed very slightly, and I like the look of it. A little bit of green creeping in, I have to say, around the tidal extension area, particularly of M51 right there. So I'm going to try and tackle that now as well, using SCNR. Now, a full power SCNR can alter the color balance of your image quite significantly, I think. So if you just want to apply it a little bit turned down, maybe half strength, also still has the effect we're looking for. Does it a little bit more gently though, overall. So I'm quite happy with that now. Next up, I'm going to pull the stars out of this image. We're going to saturate those separate to the rest of the image. It's going to be quite a lot easier for us to process that way. So running StarXTerminator now. Okay, looks to have done an absolutely wonderful job. there you go. There's just background galaxies left in that shot right now. Quite happy with that. And the stars over here. Now these stars could stand a fair bit more saturation, I reckon. So I'm going to give them it right now. So make sure the stars are selected. Create a preview window. Saturation. Once again, you can choose to just zoom in a little bit on this if you'd like and see what the effect you kind of have in taking it from being a bit neutral to definitely some differentiating colors between these stars. Overall, I'd say that's looking pretty convincing to me. Go ahead, reset the curves, close that down, and now we can move the stars across to one side. Overall, I think I'm pretty happy with those at this point. I think it's going to work just fine. Now, in order to saturate the Galaxy M51, these little neighbors just down here, I am going to try to utilize a range mask. So, process, whoops, mask generation, range selection, create a preview window. I'm going to utilize screening for this and just start by raising the lower limit until we've got, effectively you can see if I was too far left, we'd have loads too much selected. If I was too far right, it'd be a bit too selective. It's a balancing act, but you have got some leeway as to, you know, what an acceptable mask would look like. Any of this is probably going to be fine, but for me, I reckon about there, it's going to have the effect that I'm looking for. I'm going to go ahead now before I create that mask and apply a decent amount of smoothness to it overall, and I do mean a decent amount on this. And while you could turn screening mode off, I think it's probably better to leave it on this. It's going to concentrate some more of that mask's intense areas around the core of the galaxy, which I like the look of. Experiment though, that's the key thing. Just, you know, try different ways. So, drop that range mask on. Curves with our M51 Starless image selected. Preview. Saturation. Let's start to work on this thing a little bit. So, one decent curve of saturation. No problem whatsoever. You could take that second step for certain. You could take that third step. I'm thinking it could take that fourth step as well. If you just preview before and after, it certainly can. So we'll go ahead. I think 5 steps with that strength of curve would be just one step too far though. So we'll peel back very slightly on that and maybe just apply a slightly weaker last step. But I do like a coloured M51 like this. I think overall that looks, actually I'm pretty happy with it already. That looks really quite nice. When the stars go back into this, it's also going to bring in those knotty nebulous regions too, which got removed as part of the star mask, given that they were very small in this type of pixel scale image. I think I'm quite happy with that at this point. It really doesn't need much else. So I'm just going to go ahead and remove that mask. Perhaps there's a small amount of green creeping in, but it's really not that notable, to be honest. But if you just want to try to get rid of it from your image, again, a weak SCNR does alter the color balance slightly, particularly around the core. It's more notable, I think, than anywhere else. But that's looking satisfying now. I'm very, very pleased overall with that. So we've introduced a little bit of noise as part of this stretching, but it's nothing dramatic. So at this point, let's get these stars put back in. I've provided, as part of the download, some rescreening tools if you'd like to use those. So Starless, stars on the stars image. I'll close down that mask as well, get rid of that thing. And rescreen Starless and stars on any of the images. And there you go. You should have a rescreened result. So I'll just go ahead and close the rest of the clutter for a moment and hope desperately we don't have to go back. As I've just closed everything. But yeah, overall I think that looks incredible at this point. I'm very, very happy with it, even if I do say so myself. There's loads of colour in the stars. It's just overall a pretty image and a very deep image. And as I said, these nebulous regions have gone back in now. Small amount of noise crept in, but it's really nothing much. But just for the sake of showing you how NoiseXTerminator works on an already non-linear image, I'll just go ahead and apply it at defaults once again. And overall, there you go, you know, totally noise-free image without it looking fake or anything like that. It's just astonishing what can be done, I'd say, with tools and very little time. I've been running less than 20 minutes, including waiting time for these tools to apply, including experimenting time, getting that gradient removed. We've gone from, you know, linear data that needed everything doing to it, to finished data that just looks, I think it's fair to say, pretty darn good. So I hope you've enjoyed this brief tutorial and run through, and if you want to take part, like I said, in the processing challenge, then please do. I'd love to see what you've been getting up to, and other people seem to enjoy it too. So yeah, take part with the hashtag, once again, WhirlpoolWorries on Instagram, and I look forward to seeing your submissions. So thank you so much for your support. I really do appreciate it. Again, check out those links if you wish to buy these tools. It really would be greatly appreciated. And once again, thanks to people who have checked those out, and all the support that you guys give aside from that in all the various ways that you give it. I really truly do appreciate it. So that's it. Let's not go on any longer. It's been quite long enough. Hopefully you've learned something from this and found something to take away into future images. That's all I'm looking for. So thank you very much indeed for your time. Look forward to seeing you in a future video. Gliss, guys.